So, yes, Connor.
Find the distance from P to R.
In that case, if you're going to find a distance from P to R, I'd find the SY and the SX and do the hypotenuse to get P to R.
So that's like is that like the literal distance or is that like the distance the particle?
As the crow flies, so to speak, direct line straight forward. You won't be asked to do the curve if that's what you're asking. That'd be too complicated. Just the displacement, P to R. All right, so let's do this really quickly. So we have a lot of information about this one here. We know it goes at 60. And then we know that this is 60 sine 30. And this is 60 cos 30. 60 sine 30 is actually 30. And 60 sine cos 30 is 30 root 3. Now, to guarantee a collision, I would like both SYs of each particle to match each other. So to guarantee that it matches each other, what we do is we say that gets thrown up at 50. Its UY, or sorry, its VYs would be the same. So that has to be 30 as well. Well, then I can say opposite over adjacent. Then I can say sine B equals 30 over 50. And sine B equals 3 over 5. Right, so that one's done nice and quickly. Next thing we're going to have to find is the distance from P to R. So, what I think we're going to do is we're going to use 8 equations this time. 8 equations, okay? So, that'll be 40 by the way, because if sine B is 3 over 5, cos B will be 4 over 5. Going to create 8 equations, and what I can say is that S1 plus S2 will have to equal 100. Does that make sense? Or the distance along the x, so Sx1 and Sx2 is 100. The distance traveled along the x-axis at the same time has to equal 100. That's our link. That's what we're going to attack, that formula there. Okay? So, I'm going to create all eight equations right now. Vx for the first set is simply 30 root 3. Vy is 30 minus gt. I think we're just going to use 9.8. 30 minus 9.8 t. Sx 30 root 3 t. Sy 30 t minus 4.9 t squared. That's the first one. Now for the next one. Vx is 40. Stays at 40. Vy is 30 minus 9.8 t. It's actually going to be the same equation, isn't it? And Sx is quite simply 40t. Now, the distance traveled by the first particle along the x direction plus the distance traveled by the second particle along the x direction has to equal 100. Does that make sense? All right. Has to equal 100. So, all right. So, we're going to add 30 root 3 to 40t. 91.9615 t equals 100. Then divide it. or 100 divided by the answer we just got. 1.0874. Okay. Next thing you're going to do is find the distance of P to R. Well, that's easy now, because the distance of P to R, all we need is the Sx value and the Sy value using a time of 1.0874. Close that. Now, let's do Sx. Sx is 30 root 3 times 1.0874. Sy is 30 times 1.0874 minus 4.9.0874 squared. Lob it all into the calculator, and we get 30 root 3 times 1.0874. 56.20503. And the other one, 3 times 1.84 9 4 squared, 26.828. So from a diagram point of view, you're 56.3 across, and what's it, 26 points? 2a. You're going to do Pythagoras' theorem to find the hypotenuse. Not a bad question, to be honest. Square root. (62.54 meters or 62.5 meters). Got that? Now, just going to read through the next one. See what the crack is, okay? See if there's any tricks. A plane is inclined at 30 degrees to the horizontal. Particles projected up the plane with speed u, theta to the inclined plane. So look, it's a standard setup at the moment. Nothing that you haven't done lots already. Oh, now we go. Now it's not standard. A second particle is projected up the plane from the same points with the same initial speed, but an angle alpha to the inclined plane. So the first one goes like this and comes down. The second one, we don't know if they're going more obtuse or more acute. We actually haven't got a clue. Okay, let's read further. If the two particles hit the same point on the inclined plane, but the two particles hit. So what we're saying is two different angles, same range. Do you get what I'm saying? Two different angles, same range. So here's what you do. Just do it for one angle. Just do it for angle theta. And what you're hoping is you get a quadratic equation where it gives you two values of theta. That's what you're hoping for. Maybe. Let's keep reading. Two particles hit the same point on the inclined plane. The plane of projections, yeah, that's no bother. Find the time of flight for each particle. Show that the ratio of the times of flights. Alright, they actually want you to treat them separately, as it turns out. So what does it want from you? Find the times of flight. So what I want you to do is do 8 equations. I then want you to do sy equals 0 for both of them. I want you to find the time of flight for both of them, and then do one time of flight divided by the other time of flight, and what you're hoping is it turns into sine theta over sine alpha. Find in terms of u the range when theta equals 45, and hence or otherwise show that alpha equals 15 degrees. I'd still be trying my initial idea of trying to get a quadratic and finding two different values of theta. That's what I'd be thinking. Alright guys, you're gonna give that one a go. You go home, you can start now if you want. And then you're allowed to do any projectiles question that hasn't got a bounce in it. You get what I'm saying? Do any projectiles question that hasn't got a bounce, and I'll correct more of them on Wednesday. Okay, that's it.